Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about transformers. We talked about transformers in our previous book of electricity. In the chapter 13, episode number 2 or 3, we talk about transformers. It's basically the same. Those transformers that we talked previously are like this. We have step-up transformers, step-down transformers, and isolator transformers. Right now, in this video, I am going to explain the procedure to calculate the value of the output voltage, output intensity. If you have information related with the input voltage and input intensity and input amount of turns, we are going to calculate in the output or vice versa. This is a nice video. I hope that you enjoy this video. Okay, this is, for example, an example of a step-down transformer. In the input, I have 120 volts AC. And in the output, there are different possibilities. 60 volts between this and this, 40 volts between this and this, 20 volts between this and this. Yeah, it's a step-down transformer. It's very, very, very useful. In the page, you have in this moment two transformers. This one, the first one, this one is for electrical circuits. And this one, the second one, is for electronic. If you see the terminal, the legs, those legs are ready to be inserted in the circuit board and soldering. Both of them have the same function, but this one, the second one, will be integrated in a circuit board, and the first one is for an electrical circuit. There are a lot of examples of a step-up and step-down transformers, and now we are going to do the calculation for both of them, for a step-up and a step-down, and I am going to solve it, a real example, in order to practice the calculation of transformers. This is the theory related with transformer. I am going to explain right now what is the meaning of that. I have an example of a step-up transformer, electronic step-up transformer. You remember in our previous class the explanation about the inverters? You remember in the inverters, I explained that depending how you configure the batteries is the output of the inverter. If I configure the batteries in 12 volts DC, in the output, probably I have 120 AC, because internally in the circuit board of the inverter, you have a step-up transformer. If you configure the batteries in 24 volts, in the output, probably you have 220 to 40 AC. This is the example. Look, internally in the circuit board of the inverter, you have a transformer. And in the transformer, in the input, you have a DC current. And in the output, you have a 220 or 120 AC, because this is a step-up transformer, a step-up transformer. This is a typical example. You have more step-up transformers in other equipments. For example, internally in amplifiers, a lot of electronic equipment, electronic devices, they have step-up transformers. And other common example is the step-down transformer. This is the step-down transformer. This is the project that we are going to do in this class. I need that you buy a small plain circuit board, like the board that you have on the screen right now. The price of that circuit board is $1 or 0.5 cents of dollars. It's nothing. And we are going to buy those elements: 4 rectifier diodes, 1 electrolytic capacitor with a capacity of 1 microfarad, 1 resistor with a capacity superior to 1 kilo ohms, and you don't need to buy the step-down transformer. I am going to provide the step-down transformer for yours, and you only connect your circuit board with my step-down transformer, and at the end, we are going to check how was the process of rectification and if your rectifier is working properly. We are going to do this. This is the typical example of a step-down. This is a transformer, a step-down, equal to this, step-down, exactly like this one. We are going to use this one to check if your rectifier is good. I am going to connect in the input 120, and I am going to be ready. I connect female terminals for positive for my output. This one, the input is 120 and the output is 28 volts AC, because it's a step-down transformer. I have 120 here and 20A in the out. Exactly like this. I have 120 volts at the input and 20A in the secondary of this transformer. And I am going to create that bridge of diodes. I am going to connect rectifier diodes in this way, in this position. The position is critical. If you connect the diodes in opposite direction, you never rectify the current. And pay attention how I am going to connect my terminals. The hot will be connected in one diagonal and the neutral in the opposite of this diagonal. And in the output, I have DC. One will be negative and the other one will be positive. After that, I am going to install one capacitors and one resistors in order to rectify the little modulation on the signal and convert that signal completely straight. That's the situation. The function of this capacitor and this resistor is straight the last portion, because at the end, in between this point and this point, the signal is a little alternating, a little. And with the capacitor and the resistor, you straight the signal completely, and finally that signal is perfect, completely straight DC. We are going to do that project. You need fabricate in a small circuit board this portion of the rectifier, and I am going to supply the transformer. We are going to meet in the laboratory. I am going to send to you the information. What day will be the meeting? And you only connect, and we verify if you did properly your circuit board. This is an example of a step-down transformer. There are millions of electronic equipments that use step-down transformers, and we are going to check how those transformers works. Okay, this is the procedure to use a step-up transformer, step-down transformers. There are a lot of equipments, electronic equipment with a step-up and step-down transformers. And right now, I am going to explain to you the procedure to calculate the transformers step up and step down, and we are going to solve it a real example related with transformer. And also we are going to talk about the isolator transformer and what is the meaning of isolator transformers. In marine applications, we are going to use three types of transformers: isolator transformer, step up transformers, and step down transformers. In simple terms, a transformer is basically an iron frame with two coils, one in front of the other one. As you know, if I have one coil here and other coil in front of the other one, the AC current produces mutual induction. If I put this coil powered in front of the second one, not powered, the power from this coil passes to the second one for induction, and the second one is powered. What is the advantage when the power is passed to the other side by induction? The power in the second side is clean. And if you remember in chapter 10, the isolator transformer is a transformer with two coils exactly the same, with the same amount of turns, both of them. The advantage is in the first one, the power enters contaminated with noise and interference, and in the second one the power will be completely clean. Check my video, the video about galvanic isolator versus isolator transformer. I explain the function of the isolator transformer. In other words, the isolator transformer have equal coils, one in front of the other one, equal amount of turns in both sides. In the second side, the current will be completely clean and the signal is clean. This is the isolator transformers. Exactly the same coil, one in front of the other one. The step up and step down transformers are, for example, a step up transformer is a transformer with more turns in the secondary coil. More turns in the secondary coil, then the voltage will be higher and the intensity will be down. And in a step-up transformer, the output voltage increase, the output intensity decrease because I have more turns in the secondary. In a step-down transformer with less turns in the secondary, I have lower voltage because it's a step down, but I have more amps. A step-up transformer, more turns, increase the voltage and decrease the intensity. A step-down transformer, less turns in the secondary. What is the meaning of that? Decrease the output voltage and increase the output intensity. I have a good example related with this. The example is this. Suppose that I have in the primary coil, this is the primary coil, the voltage, the intensity, and the number of coils. The voltage is 1000 volts in the primary coil. The intensity is 2 amps in the primary coil. And the number of coils in the primary is 50 turns. And I know about the secondary coil only the intensity. The intensity is 10 amps. The question is, how much is the voltage in the secondary and how much is the amount of coils in the secondary? We are going to use a simple formula to calculate that. What is the formula when you talk about transformer? The formula is simple. Remember, if I have power in the input, the power passed to the secondary by induction. But the power is exactly the same in the primary than the secondary. What is the meaning of that? The input power should be exactly the same like the output power. The input power, according with the formula, is voltage times intensity. Voltage in the primary times intensity in the primary. Should be equal to the power in the secondary. Voltage in the secondary times intensity in the secondary. Okay, if I have this one equal to this, I can organize that formula in this way. Voltage in the primary divided by the voltage in the secondary should be equal to intensity in the secondary divided by the intensity in the primary, and also should be equal to the number of coils in the primary divided by the number of coils in the secondary. This is the magic formula. With that formula, we can solve it transformers. We can calculate how much is the voltage in the secondary if I have information related with the primary or vice versa. In this example, I am going to use the same formula. Voltage in the primary divided by the secondary should be equal to the intensities and should be equal to the relation related with the number of coils. Okay, what information I have? I have 1000 volts in the primary divided by the voltage in the secondary. This is one of the questions. And should be equal to the intensity in the secondary, 10 amps, divided by the intensity in the primary, 2 amps. And should be equal to the number of coils in the primary, 50, and the number of coils in the secondary. That's the second question. And we can solve it easily. Voltage in the secondary is 1000 times 2 divided by 10, 200 volts. And number of coils in the secondary should be 50 times 2 divided by 10, 10 turns. With this magic formula, we can solve it transformers. Remember, transformers there are 3 types of transformers. Isolator transformers is used only to clean the signal. Step-up transformers, I increase the voltage, but the intensity decrease. And step-down transformers, I decrease the voltage by the intensity increase. Why the intensity increase when the voltage decrease or vice versa? Because the power is constant. If I increase the voltage, the intensity decrease. If I increase the intensity, the voltage decrease. This is basically the theory related with the transformers. You found that information in the page 237 of our electrical book. Now I am going to explain the procedure to wiring a transformer in the panel of your boat. Remember, you have 3 possibilities for transformer: isolated transformer, a step-up transformer, or a step-down transformer. Isolated transformer is mandatory in the installation in the wiring of a boat. Remember, where should be located the isolated transformer according with my recommendation? I recommend install the isolated transformer after the switch selector. In between the switch selector and the main panel on the AC panel should be located the isolated transformer. In this particular case, I have an isolated transformer. The isolated transformer, remember, have equal coils, equal turns in both sides, in the primary and the secondary, equal amount of coils. What is the meaning of that? That if I have 120 volts at the input, I have 120 in the output. If I have 240 in the input, I have 240 in the output. The voltage will be exactly the same because the amount of turns in both coils, primary and secondaries, are the same. This is the isolated transformer. Where is located the isolated transformer in a boat? According with my recommendation, the isolated transformer should be located. This is the output of the switch selector. This is the output of the switch selector. The power enter in the isolated transformer, and the power continue and enter in the main breaker of the AC panel. According with my recommendation, the isolated transformer should be located in between the switch selector and the main panel. Why? Because in this location, I clean the signal coming from generator, or coming from inverter, or coming from short power. All of those three signals are cleaned, and the signal will be completely clean in the output of the isolated transformer. This is the example specific of isolated transformer. What other type of transformer is commonly used in marine application? Other transformer commonly used in marine application is the step-down transformer. In what situation you found a step-down transformer? The most common situation is in European boats. Remember, in European boats, in each phase is produced 230 volts, 50 hertz. But normally in the outlets that you have, the regular outlets, the regular outlet that you have in any socket are, if it's American, is 120 volts, 60 hertz. If it's European, it's supposed that is 110, 115, 50 hertz. For that reason, in European boats, in the main panel, where the phases enter, after each phase, they have one step-down transformer. Each phase is 230, 50 hertz, and the step-down reduce the voltage to 115, 50 hertz. It's a step-down transformer that reduces the voltage from 230 into 115. For that reason, you founded adapters for European boats, adapters like this. Adapters like this. In the input, this is the outlet for European boats, rounded in both sides, hot and neutral, and the ground is here. Hot, neutral, and ground here. 230, 230, 50 hertz. And with this step-down transformer, you convert 230, 50 hertz into two outlets, 115, 50 hertz. 115 and 115. You have a European boat, and you install this step-down transformer, and you convert this phase, 230, 50 hertz, into two outlets, 115, 50 hertz. You see, you reduce only the voltage with the step-down transformer. The frequency is the same. What is the inconvenience with those outlets? Those outlets right now are 115 and 115. Okay, it's pretty close to 120, the American power. But remember, the frequency here is 50 hertz because you reduce the voltage. The transformer is used to reduce the voltage, not the frequency. The only way to change frequency is when you adjust the RPM on the engine. With the transformer, you only reduce or increase the voltage, not the frequency. In this particular case, we are going to reduce the voltage from 230 into 115. However, the frequency stays constant, 50 hertz and 50 hertz. This is a typical step-down transformer. It's commonly used in European boats in order to reduce the voltage in outlets like this. This is a good example. Step-up transformers are not commonly used. Internally in the inverter, we have a step-up transformer that I am going to explain later in the chapter 15. Okay, what is the procedure to do the wiring with transformers. If I have a transformer like this, suppose that this transformer is a single phase. This is a typical transformer single phase, and I am going to do the wiring right now. This is the input, this is the primary. In the primary, I have the hot and the neutral coming in. Suppose that the hot and the neutral coming in is 120 volts, 60 hertz. If I have the same amount of coils in the secondary, of course, I have 120. And this is the neutral, and after this point, this end will be hot line, and this end will be the neutral. And remember, only at the source of the power, neutral and ground are together. This is the source of the power. In this point, the ground is together with the neutral. The ground is together with the neutral. This is the ground. From this point, the cable continue white color, neutral. And we have another separate ground from the frame of the transformer going into the boat like ground. This one will be the neutral, and that one will be the, the ground, and this one will be the neutral, and this is the hot. Remember, inside of the boat, the bus bar of the neutral and the bus bar of the ground should be separated all the time. Why? Remember? Because if you mix this with this, and for some reason you have reverse polarity, right now your neutral bus bar is hot, and because the hot is together with the ground, the corrosion in the boats increase, and you can destroy the boat. Once again, inside of the boat, neutral bus bar and ground bus bar should be separated, and you need to be careful with reverse polarity. Reverse polarity probably in your home is not critical, but in a boat is critical, is catastrophic. All right, this is the procedure to connect a single phase transformer. And those are the lines, hot, neutral, and ground, that enter into the main panel and continue in the boat. Suppose that the transformer is not a single phase like this, it's a double phase transformer. If I have a double phase boat, of course I have a double phase transformer. The procedure to wire a double phase transformer is like this. This is the input. Phase number 1 is black color, phase number 1. In this point finish the phase number 1 and continue. But in this point, touch the frame and is connected with the neutral. Remember, only at the source of the power. And continue the second phase. Okay, this is phase 1, the red one. Continue. Phase 2, and this point is the neutral point. That's the neutral point. In the output, I have exactly the same. Phase number 1, finish here, and continue here. Phase number 2, and this point in the middle will be the neutral. Okay. This point in the middle touch the frame. Touch the ground, because this one is the ground. From any other part of the frame, I go with a separate cable with ground. Only at the source of the power, neutral and ground are together. And this one in the future continue like phase 1, neutral, phase 2, and ground. And this one will be the neutral. That's the procedure to wire a double phase transformer. Of course, if it's 3 phase, it's exactly the same. Thank you.